Hi everyone. Food irradiation is most definitely a superb food preservation option, imparting great safety for human consumption by virtue of prevention of undesirable sprouting of veggies, protection from insect infestation, not allowing pathogens to enter the food and multiply there, thus extending the shelf life of the food considerably. This therefore reduces episodes of food spoilage as well as foodborne diseases. Many radiations such as gamma rays, X-rays and electron beams etc. are used industrially due to their good penetration power. Among these, gamma radiation is most common, but its strongest penetration power could be damaging for the workers too. Hence, the food is smartly placed on remote controlled and automated conveyor belts which are made to enter the processing room or irradiation room with thick radiation proof walls, irradiated there adequately and brought back via the same conveyor belts which are remotely controlled. No personnel are supposed to enter these rooms for safety concerns. Radioactive cobalt-60 or cesium-137 is made to emit these rays, which penetrate deep into the cells and DNA of live microbes and annoying pests present in the food, hence killing them without raising the temperature of the food product. UV rays or ultraviolet rays may also be occasionally used to irradiate the foodstuff, but only when the surface sterilization is to be done, since their penetration power is very poor. In recent decades, the use of microwaves, which are electromagnetic waves lying between infrared and radio waves, of typically 915 or 2450 megacycles, has become very popular, that prevents food spoilage essentially via producing enormous heat. In 1920, a German named Otto Wust discovered that ionizing radiation could preserve food and filed for a patent from the French government. A couple of decades later, Massachusetts Institute of Technology, MIT, also endorsed this method to be worthy and useful. In 1980, a committee of the Food and Agriculture Organization FAO, the International Atomic Energy Agency IAEA, and the World Health Organization WHO jointly declared that an overall average dose of radiation of the range 10 kilograms was safe for food products. In this context, the maximum energy emitted by cobalt-60 and cesium-137 is too low to induce radioactivity in food and hence safe for human consumption. Irradiation of the foods is done at three broad levels by delivering ionizing radiations at a dose that's just enough to inactivate microbes to a safe limit, which are termed radicidation, radiorization, and reductization depending on the intensities of radiations employed. Radicidation is an irradiation process just enough to inhibit sprouting of onions, potatoes, and garlic, and for general reduction of some specific non-spore forming pathogenic bacteria. Radiorization is a dose of 1 to 10 kilograms that, like pasteurization, is useful to target specific pathogens. Reductization is much superior. It's a strong dose in the range of 20 to 30 kilograms necessary to sterilize a food, especially the exotic ones, for them to have a much longer shelf life. Although expensive, but several countries have permitted preservation by irradiation for certain foods, and indeed it turns out to be very useful for purposes like inhibition of sprouting of certain veggies, reducing perishability of delicate fruits like strawberries, mangoes, grapes and cherries, and insect disinfestation of pulses, cereals, peanuts and dry fruits. Using irradiation as an alternative to heavy doses of pesticides is definitely most attractive. The FDA allows exposure to food of approximately 10 kilograms, foods such as fresh poultry, meat, seafood, fruits and veggies, spices and condiments, seasonings and cereal grains. It's an entirely safe process. It can prevent food spoilage as well as foodborne illnesses. And contrary to the popular myth, the irradiated food stuff does not turn radioactive at all, provided it's not over irradiated. While irradiation is very effective, still there are some limitations to it too. Foremost is that it's an expensive treatment, and also a special irradiation plant and expert workers are throughout needed for it. Furthermore, if it's done in the absence of oxygen, radiolysis of lipids leads to formation of certain chemicals which may render the food rancid and unacceptable. Some vitamins are also sensitive to irradiation, and protein nutritional losses may also occur at high doses of radiation. So guys, we hope that this content did make you understand the concept as well as its pros and cons. Do not hesitate in commenting your feedback and queries in the comment box. Thanks a million for watching and appreciating our videos. We'll be back with more of such simplified concepts of food microbiology just for you. Bye till next time and take care.